Your whole life, what you are going to do, how you are going to live, how much you are going to live, not in terms of your age, but in terms of your opportunities, success, and your upcoming days, is completely depending upon the remaining 7 months. So, put your best, that only I will say. Put your best, give your best, and then only you will be able to do something good in your life. Moreover, some of you would have realized by now, at least by now, that you are not giving your best. School exams are happening, school results are coming, you would have got the papers recently, and you know how you are performing. Most of you are not performing to what you want to perform. Where you are lacking, find the gap, work on those areas. If you are going to be just like a stone, then your life is also will be like a stone only. If you want to shine like a diamond, then you have to get that pressure of becoming a diamond. So please take my words very seriously. It is going to be tough. The coming days are going to be further tough when you are going to have more pressure from all the directions. School will be on the verge of finishing syllabus in 2 months. Everybody will keep tests. Everybody will say you study this, study this, study this, study this. This is the time when you will face all these things, and you have to face this struggle and do your best. Everybody is training you for one thing only, your board result, your exam result. You cannot say school is misguiding you. You cannot say I am misguiding you. You cannot say anybody else is misguiding. Everybody, your parents, your teachers, me, everybody in Wisdom Academy wants you to do good in your future. I hope you have that much faith on us, that we want everybody sitting here to do extremely good in their future. And for that, what we can do from our side, we are doing it for you. But most of you will be feeling that I am attending class, I am doing worksheet, then also I am not able to convert this into result. Identify where you are lacking, guys. If you become serious one day before the examination, things will not work out. Your seriousness should be for the entire time. If you are still not serious for your coming days, then you are going to have a very bad time. Most of you are writing your term examination or going to write your term examination. Most of schools have finished volume 1 and they are going to start volume 2, those who are going in the order. Or some schools have started volume 2 already, that is optics. Here also we have done AC, EMW is small thing which will be very soon done, and then we will start ray optics. But again I am repeating, my aim is not to complete syllabus and send you off. I always want you to understand the things and increase your ability of solving questions, because physics is all about analyzing. More than theory, physics has numericals and the concepts. So today I thought of finishing that remaining part of EMW, starting ray optics, but then I thought it looks like we are going a bit fast. I am not practicing sufficient numericals from EMI and AC. Today's class I am going to dedicate only for numerical solving. Today, another half an hour, I will be revising EMI and AC, a quick revision, not in a detailed revision, a quick revision I will give, and with that quick revision, I will open some questions in front of you, mostly MCQs. I will give you an idea how the questions are being asked from EMI and AC. That is very important to understand how the questions are coming. So we will do that today. So first half an hour max to max, we will revise the portions of EMI as well as AC. 2 chapters I am revising now. And then 1 hour we will be doing only the question solving. We will try to solve at least 25 questions today. That is my aim. Minimum 25 questions we will solve today from EMI and AC together. But before my question solving starts, let me recall all the concepts of EMI and AC once again for you. Shall I? You are ready for that? Okay. So we will start the revision. First I will start with EMI. Everybody please pay attention. Something you want to ask, stop and ask me. Something you are asking, Sharon? No. Okay. So we will start with EMI. then we will go down to AC before we start taking the numericals. So first, in EMI chapter, how it started? It started with the concept of magnetic flux. So the first topic in this chapter was magnetic flux. What is magnetic flux? Magnetic flux is the number of magnetic field lines passing normally through an area. And what is the mathematical formula of magnetic flux? Phi is equal to BA cos theta, where what is theta? Angle between magnetic field and area vector. So if you have magnetic field going like this and you have area like this, then the angle between B and A is not 90, it is 0 degree, because area vector will be in this direction and area vector and magnetic field are parallel to each other, making theta as how much degrees? Realizing? Okay. Then we have learnt what is Faraday's law. So Faraday gave two laws. Faraday's laws were based upon the concept of electromagnetic induction, where Faraday discovered that whenever there is a change in magnetic flux, there is an induced EMF, and this induced EMF will last only till there is a change in magnetic flux. If the coil is a closed coil, there will be induced current also. Second law, he gave the quantification of this. Quantification means the formula of Faraday's law, electromagnetic induction. He said that E is equal to d phi by dt. That is, if you differentiate the function of magnetic flux, you get induced EMF. So induced EMF can be found by differentiating magnetic flux. And if you divide by resistance, you will get induced current also. Then we learnt the Lenz law. Lenz law works in accordance to law of conservation of energy, and Lenz law says that direction of induced EMF will be in such a way that it will oppose the cause of it. That's why I am having a minus sign in front of it. Minus sign indicates that induced EMF will have a direction opposing the change in magnetic flux. So E is equal to minus d phi by dt. Lot of numericals we have solved based upon Lenz law, where you saw a coil entering the magnetic field, coil exiting the magnetic field, magnet going inside the coil, coming out of the coil, wire is increasing current, decreasing current. So in each question, the concept remains the same. Step 1, identify whether magnetic flux is changing or not. If magnetic flux itself not changing, no induced current. If magnetic flux is changing, check whether it is increase in magnetic flux or decrease in magnetic flux. Accordingly, put the direction of induced current. If it is increase in magnetic flux, try to reduce it. If it is decrease in magnetic flux, try to increase it. Then we have learned the concept of motional EMF. What is motional EMF? Motional EMF is the EMF which is produced across the ends of a conductor when it is made to move in a magnetic field. And we got the value of motional EMF as B, L, V, where V is the magnetic field, L is the length of the conductor, V is the velocity of the conductor. So B, L, V is the expression for motional EMF. Then we learned in this chapter about self-inductance and mutual inductance. We came to know self-inductance L is given as phi by I, one formula. Another formula is, it is also given by minus E into di by dt, isn't it? Actually minus E into minus E divided by di by dt. From here I defined what is the self-inductance formula. Self-inductance is defined as flux per unit current. A better definition for self-inductance is opposing EMF per unit rate of change of current. SI unit can be Weber per ampere, called as Henries, or volt per ampere per second also. You may get a question. In that option, Henry will not be there, but volt per meter per second will be there. Ampere per second will be there. That will be the answer. So be clear, the formula should be in your head. We have also found the mutual inductance formula, which is equal to phi S by IP. That is flux in secondary coil per unit current in primary coil. If I write in terms of EMF, it will be minus ES by DIP by DT. Opposing EMF in secondary coil per unit rate of change of current in primary coil is the definition of mutual inductance, and the unit is same is Henry, because here also Weber per ampere, same. We have also found for a long solenoid what is the value of self inductance, and we have got the value of self inductance as mu naught n square A by L. If n is number of turns, per unit length, it is mu naught n square A into L. We have also found if there are two solenoids which are having mutual induction, then between them the mutual inductance M is given by mu naught N1 N2 A by L. These things we have derived in the class itself. After that, we have found what are the methods of producing induced EMF, and we have come to know that E is equal to E naught sin omega t, where E naught is given by N B A omega. What is N? Number of turns. What is B? Magnetic field. What is A? Area of the loop. What is omega? Angular velocity. Omega is given by 2 pi by T, isn't it? This formula, or 2 pi nu, whatever you want to call it. So induced EMF E is equal to E naught sin omega t, where E naught is NBA omega. This is all there in EMI chapter. So whatever question is going to come in EMI, it is going to come from any of these explanations. I will show you how the questions are coming, but this is the core from where the questions are being asked from EMI. Then comes alternating current chapter. Let us revise alternating current also. In alternating current, we started with the derivation of RMS value of AC current. If you remember my lecture, first thing that I have done is I have taught you how to derive by using integration RMS value of AC current. What is the meaning of RMS value of AC current? Not the formula I am asking, meaning I am asking. RMS value of AC current is that value of steady current equated, that's all. So we will find the heat produced by passing AC, and we will equate with DC, and we will find the value of current. If you do that derivation, you will get the value of IRMS, and how much you will get IRMS as? IRMS is 0.707 times of I naught. So I can say that RMS value of AC current is 1 by root 2 times of peak current, or I can say 70.7% of peak current. So whenever you write the equation of normal instantaneous current, I is equal to I naught sin omega t, you should have the clarity of what is the meaning of the word I, what is the meaning of the word I naught, and what is the meaning of the word IRMS. All are different. This is called as instantaneous current, which gives you the value of current at a particular instant t. I naught is a constant value, which is the peak value, and IRMS is the measured value of AC, which is 1 by root 2 times of peak current. Don't confuse, questions will come directly from here. Then we connected resistor across a alternating current circuit, or we connected inductor across alternating current circuit, or we connected a capacitor around alternating current circuit. These things were done in the previous class, where we came to know that if E is equal to E naught sin omega t, in this case I am going to get I also as I naught sin omega t. It means current and voltage are in same phase. Very, very, very important, where I naught is equal to E naught by R. I have drawn the phasor diagram in same phase. Then in this case, if E is equal to E naught sin omega t, then we have derived and found I is equal to I naught sin omega t minus or plus? Minus pi by 2. It means current lags behind the EMF by 90 degree in the case of purely inductive circuit, where What is I naught here? I naught is E naught by XL. XL is called as inductive reactance, which means resistance offered by an inductor. Its SI unit is ohm. This question will come in the examination. What is the SI unit of reactance? Answer is ohms if it comes. And then what is XL? XL is omega L. And what is omega? Omega is 2 pi nu. So 2 pi nu L. For DC, what is the value of nu? 0. So for DC, nu is equal to 0. So what is the value of XL? XL will be also. It means inductor offers 0 resistance for DC current. Then with this circuit, if E is equal to E naught sin omega t, then what we got the value of I? I became I naught sin omega t plus pi by 2, which explains that current is 90° ahead of EMF, and the value of I naught is how much? In this case, what is the value of I naught? I naught is equal to E naught by XC. What is XC called as? Capacitive reactance, same as inductive reactance, its unit is ohms. And what is the meaning of capacitive reactance? Resistance offered by capacitor. And what is its value? If I write what is XC, then I can write here XC is equal to 1 by omega C. 1 by omega C, it means 1 by 2 pi nu C. If nu is equal to 0, XC will become infinite. It means for DC, a capacitor offers infinite resistance. Very, very, very important. This question has come multiple times in the examination. For DC, the inductor offers no resistance, capacitor offers infinite resistance. Then,
there is no current flows to the circuit.
What, Mithun?
So then current should not flow in that.
It will not flow. It will not flow because there is infinite resistance, isn't it? So now we come to LCR circuit. We also learnt LCR circuit, that is series LCR circuit. When I connect inductor, a capacitor and a resistor in series to E is equal to E naught sin omega t, isn't it? If E is equal to E naught sin omega t, here I will get I is equal to I naught sin omega t plus or minus phi. You know why I am writing like this? It depends upon whether it is predominantly inductive or predominantly capacitive. If it is predominantly inductive, then I will become I naught sin omega t minus phi. If it is predominantly capacitive, I will become I naught sin omega t plus phi. In each of the case, the value of phi will be tan inverse of XL minus XC by R or XC minus XL by R. Totally depends upon whether it is predominantly inductive or predominantly capacitive. I hope you get my point. Then we have found resistance offered by LCR circuit is called as impedance. Impedance is equal to root over R square plus XL minus XC the whole square. This is called as impedance. What is impedance? Impedance is the resistance offered by LCR circuit. We have also found the value of resonance condition. After this we have learned. We have learned in resonance condition what happens if XC is equal to XL, then Z becomes equal to R. This is called as resonance condition. Resonance condition means current becomes maximum, impedance becomes minimum. And what is the frequency value? Omega R is equal to 1 by root of LC. Or if I want to write in terms of nu R will be 1 by 2 pi root of LC. Isn't it? We have seen this in the previous class. Apart from that, in this chapter, huge chapter it was, we have learnt also about transformers. And we have learned in transformers one very important concept. That concept is called as transformer ratio concept, which is NS by NP is equal to ES by EP is equal to IP by IS is equal to transformer ratio K, isn't it? And I told you, if k is equal to 1, k is greater than 1, it will become step up transformer. If k is less than 1, it is called as step down transformer. How can k be more than 1? If ns is more than np. How can k be less than 1? If ns is less than np. It means if you have more turns in secondary coil and less turns in primary coil, I am going to get a step up transformer where the voltage will be increased by decreasing the current. On the other hand, if I am going to have more turns in primary coil, less turns in secondary coil, it will be called as a step down transformer where the voltage will be reduced by increasing the current. I also told you efficiency of transformer eta is given by Vs Is by Vp Ip, output power by input power. In this chapter, we have also learnt power in AC circuit, and we got the formula of power as P is equal to E RMS I RMS cos phi, where phi is what? Cos phi is called as power factor. This is called as power factor. This is called as virtual power. This is called as real power. So, real power is always equal to power factor times the virtual power. And I told you current flowing in purely inductive or purely capacitive circuit is called as wattless current or powerless current, because if phi becomes 90, power will become 0, and phi becomes 90 in the case of purely inductive and purely capacitive. Just now we have seen it. That is all about this chapter. I just gave a quick revision. I not taught anything now. I just recalled whatever I have taught in the previous class. Now, based upon these two chapters, EMI and AC, let us see without wasting time how the questions are being asked in the examination. I have selected typical questions from the MCQ category. Okay, so if you are able to hear it, see it, is it visible to you, everybody? If it is visible to you, question 1, question 2, make it fast. Question 1 and question 2, start doing it. Question 1 and question 2. I hope it is visible to everybody of you. Don't waste your time, keep on doing. I'll do parallelly with you. If you have any doubt, you can ask me. If you have any doubt at any point, please feel free to ask me. Let's make it fast. The first question, write the given data first and check what they are asking to find and use the proper equations. Don't try to browse any answer anywhere. Do it by yourself and get the answer properly. Make it fast. Pratap, for which question you said answer C?
Yes, sir. Sir, is it option B?
Option B is told by Mithun. Anybody else saying the same answer? Shall I solve it now? Question number 2 also you have tried?
On the way, sir.
Make it fast, make it fast. Take 2 more minutes, I will solve then. I hope you are waiting for me to solve, I think. Both questions are actually easy if you understand the concept. Okay, let us see. What is given in the question? Let us first understand that. So, in the question, they have asked you to find the value of peak EMF, peak value of EMF. They are asking you to find E naught, isn't it? What is the formula of E naught?
No, it's option B only. Sorry.
Okay, let me check. N, B, A, omega. N is given, number of turns 30. Magnetic field is given. Magnetic field is how much, guys? 1 Tesla. What is area? 400 into 10 to the power minus 4, because centimeter square to meter square. What is the omega? Omega is how much? 1800 revolution per minute is not omega, yaar. Omega should be always in radian per second.
360.
Yes, so you have to convert into 1800 by 60 obviously, because for second, and multiply with 2 pi also, no? For radians. One revolution will have one circle, right? So for full circle, it will be 2 pi in radians. When you solve this, you will get the answer. I think if you solve this, you will get the answer as B. B is the answer. Check,
Yes,
guys.
sir, yes.
Yes. So N is given, B is given, A is given, omega is not directly given. But for omega, they have given the value of nu. And you know that nu, if you want to convert to omega, omega will be 2 pi nu. So I have multiplied 2 pi to get the value of omega. Is it clear? Simple question, the first one. If anybody has doubt, please feel free to ask me. Second question, anybody got the answer? Anybody who has got answer for second question? Krishna, any answer? 5 pi. Okay, let us see. Try. Some people are saying answer as C here. Check whether you are getting the same answer. Option C. Amrita says option C. Let us check. Anybody else getting some other answer? Mutual inductance from EMI chapter. So, what is given? M is given, isn't it? In this question, what is given? They have given the value of M. What else they have given? I they have given. Oh, this is omega, by the way, not ohm, okay? Omega T it is, misprinted. I naught is given, omega is given. They are asking you to find the maximum value of EMF in the second coil. So, you know formula of mutual inductance. What is that? M is equal to minus ES by dIP by dt. Do you agree with me? So EMF in the secondary coil will become equal to minus m into dis by dt, dIP by dt, isn't it? M is given. M is how much? 0.005. Only problem is dIP by dt. So we will write d by dt of what? What is I given here? I naught sin omega t. If you differentiate, it will become omega into cos omega t, isn't it? D by dt of sin omega t will become omega into cos omega t. If I do it, I am writing it here. I will get the value of ES as minus m. M is how much? 0.005 times omega. Omega is how much? 100 pi times I naught. What is I naught value? 10 times d by dt of sin omega t is cos omega t, and omega t maximum they are asking. Maximum means cos value will be 1. So I will directly write 1. If you multiply all these things, 0.005 into 1000 will give you 5 pi. That is the answer. Good. 5 pi is the correct answer. Yes, good. Those who could get the answer by themselves, I appreciate that. Answer is 5 pi for this. If you have any problem in understanding, ask me. This is how the questions are going to be asked. Don't expect that question to be there. This is all direct only, but little bit of rearrangement of terms you should do. Any problem in this question? If anybody has any doubt, please ask me. If there is no doubt, I'll go to the next question. Shall I go to the next question? Akhilesh, understanding what is happening?
Yes, sir.
So, you not got the answer by yourself, man.
Not, sir.
Then why you are not saying?
I don't know, sir, is it correct or not, sir.
Just give a try. Wrong means I will correct it. What is the problem in that? I hope everybody is understanding. Next question we will see. Okay. Question number 3 and 4. Fast.
Sir,
Both are direct
three
question.
option C.
3 option is
3 option C. D.
D.
Sir.
Direct question.
N square.
Yeah, L formula you know. Mu naught n square A by L. So answer is n square. Direct question. Third question, answer is n square. Good. Fourth question.
Option B, sir.
Magnet is moved either towards or away from the coil. EMF is induced. Magnet of which is independent of number of turns. It depends. Resistance, it does not depend. Resistance, what depends? Current depends. But they are asking for EMF. So speed at which it depends, then it depends. Yes, answer is B. Good. Answer is B because it does not depend upon resistance. It depends upon all the factors. Is it clear to you? Next question. Question number 5. Fast. Question 5. 5 and 6. Don't take much time. Fast. 5, 6 and 7, all 3. Question number 5, 6 and 7.
The fifth question, option C, sir. 0.5.
Okay.
0.5, sir.
Okay.
0.5.
Okay, good. Next we go 6. Question number 6, you go 6 and 7 also fast. I have already sent Kirti, please check. Okay.
Sixth question, option B, sir.
B in the sense, B for Bravo.
Yes, sir.
Okay. 7th question. 7th I told before some time.
A, sir.
Option
A, sir.
A.
Yes, sir.
Okay.
Sir, isn't it option D?
Option D you are saying, Pratap?
Yes, sir.
Delta for 7th.
Yeah.
Okay, let me check.
Sir, sixth one is it B, sir?
B is 4 Henry. Let me check. I will solve it. I don't know the answers. I will solve it along with you. So for the first one, They have given 5, you will you will differentiate this. If you differentiate, how much you will get? You will get 100 t, that's all, isn't it? And t is given as 2, so it will become 200. 200 will become the value of E, and divide by resistance, you will get the value of current. So 200 by 400 will be giving you how much? 0.5. Without even solving, you can say the answer is 0.5. I hope you understood. What we did? We differentiated this function because we know that E is equal to d phi by dt. If you differentiate this function, what you will get? 100 t, and t is given as how much? 2 seconds. So it will become 200 volts. If you divide EMF by resistance, you will get current. 200 by 400 will become 0.5. Simple. Sixth question was current changing from 5 ampere to 0 ampere in 0.1 second. Average EMF is 200 volt. Self-inductance they are asking. What is the formula of L? L is minus E divided by di by dt. So what is E? 200. What is change in current? 5 minus 0, that is 5. How much time it takes? 0.1. Solve this, you will get the answer. It will cut, it will become 50, 50 it will go 4 times. Again simple question, answer is 4 Henry. Seventh one is? Pratap, you said answer is D. Why man? Self-inductance I have told you already. It is EMF by this. So it will become volt divided by ampere per second, isn't it? Pratap?
Yes, sir.
If it goes above, it will become volt. Above it goes, this will go above, right? So it will become second, and ampere will come here, it will become ampere inverse. Answer is
Okay, sir.
A, isn't it?
Yes, sir. Yes, sir.
This is the way the questions are coming in the examinations. The simple questions are there. Little bit you should think only. Here. Don't expect the questions to come lesser than this level. It will not come. Whatever I am solving now, don't think it is only for MCQ category. You may have similar question coming in 2 mark also, 3 mark also, case study also, anywhere it may come. Anywhere it may come. Shall we go to the next question? I hope I can move forward. Question number 8 and 9. Make it fast. 8 and 9.
Sir, 8 on B option, sir.
B means Bravo.
Yes, sir.
Okay, ninth one. Make it fast, guys. Give it a try. For which one? Eighth one.
Eighth on option.
What you are saying, Mithun?
Silent.
Okay, somebody else
Sir,
said.
8 on option B.
Okay, B is what even Akhilesh told. Eighth one B, many of them have said. Ninth one?
Ninth one B, sir.
9 also B. B for Bravo, ball, right?
The 8th one and 9th one B.
Both are B.
B, sir.
Okay, let us try to solve it. Huh? 8 is C you are saying. Let us check it. It may be right or wrong. I don't know. So they have told the current is changing from 2 ampere to minus 2 ampere in 0.5 second, isn't it? So the formula of self inductance L will become equal to 8 volt divided by change in current from where to where? From 2 to minus 2. So how much it will become? So it will become 4, isn't it? 2 minus minus 2 will become 4. And how much time it takes? 0.05. So it will be 8 times 0.05 divided by 4, right? Litish or Lingesh? Yeah. Huh? Lingesh. So 4 2s are 8. So 0.05 times 2 will become 0.1 only, no man? .05 into 2 will become 0.1, isn't it? I hope it is clear. Any problem in this? How I am getting this, your understanding, isn't it? Change in current from 2 to minus 2, 2 minus minus 2, it will become 4 divided by time 0.05. That's all. Ninth one is little twisted. Ninth one can come in 3 mark also. This kind of question. The question is, a conducting circular loop is placed in uniform magnetic field. Magnetic field is given to you with its plane perpendicular to the loop. Okay. So theta is 0. The radius of the loop is made to shrink at a constant rate of 1 millimeter per second. dr by dt is given here. How much is that? 1 millimeter means how much here? 10 power minus 3 meter per second, isn't it? 1 millimeter is 10 power minus 3 meter. Induced EMF when the radius is 2. So they are asking what is the induced EMF when R was how much? 2 centimeter. This is the question. How do you find that? We know very well induced EMF will become equal to d by dt of what? Phi. Rate of change of flux is induced EMF. Now what is phi? D by, I'll solve now, d by dt of phi. Phi is what? BA cos theta. B is constant and it will go outside. Cos theta is going to be 1. So what is going to be A? A will be pi r square, d by dt of pi r square. Now differentiating the function. This is a good question. This question can come in competitive exam also. So B will come outside, pi will go outside. If you differentiate, it will become 2r into dr by dt. We have solved this kind of question in the regular class also. Check your notes. So when you put in the equation, everything, that is B value, R value, and solve, then you will be getting the answer as pi microvolt. This is the answer, correct. B is the answer. Good, those who have got the answer. If anybody has problem in what I have solved, please ask me. Induced EMF is rate of change of flux and flux is BA cos theta. So B will go outside. What is A? A is pi r square for circle. In pi r square, pi is a constant, will go outside, and d by dt of r square will become 2r into dr by dt. So dr by dt is known to me, r is known to me, B is known to me. Put in the equation, get the answer. Clear? Simple question only. I will not say it is a tough question. Up to question number 9, everybody has understood what we are solving. Today's class becomes more important because we are learning question solving. Shall I go ahead? Shall I go ahead? Question number 10. Options are not there, but you can solve by yourself.
Sir, how the answer is pi mu v?
By solving, man. I have erased the board also. If you solve, you will get the answer as pi. Shall I solve it and show you, man?
Yes, sir.
Okay. Let me solve it for you, no problem. Those who are doing can do question number 10 then. If I solve this, we got that time induced EMF as B into pi into 2r into dr by dt. That's what we got, right? Who asked? I think Andrew asked, if I am right, isn't it? Yes, Andrew. So B is 0.025 times pi times 2 times R. R is how much? 2 centimeter. 2 into 10 to the power minus 2 meter times dr by dt is how much? 10 to the power minus 3. Is it clear to you, all the given data? Andrew?
Yes, sir.
Okay. So I can write this as 0.025 times 2 into 2 will become 4. So 0.025 times 4 will make it 0.1. Am I right?
Yes, sir.
0.1 can be written as 10 to the power minus 1, isn't it? 10 to the power minus 1 into 10 to the power minus 2 and minus 5 pi. This much volts is coming, which is 10 to the power minus 6 pi volts, right, Andrew?
Yes, sir.
10 to the power minus is also called as micro. That's why they are writing pi microvolts. Understood?
Okay.
I hope it is clear to you.
The 10th one is it 60, sir?
10th one is 60 said by Krishna Raghavan. Anybody else got 60 as answer for 10th one? Check it fast. They have given the value of inductance. They have given the value of change in current and time.
The answer is 60, sir.
60 is the answer. Okay. 60. Okay. What formula you are using? M is equal to minus ES by dIP by dt, isn't it? So what is given here? This value is given. This is also given. Oh, this is not given. Sorry. This is given. This you have to find. If you find that, after that you have to find change of flux also. Oh, that is only called as change of flux, because change of flux is only called as E, isn't it? Yeah. So when you multiply these two, you will get the answer. What is the answer? 1.5 times change in current is 20 by time is how much? 0.5. It will become 40. So 15 4 is 60. Yeah. Here we can mention minus denotes that it is opposing EMF. That's all. Minus denotes it is opposing EMF, nothing else. Yes, if you put minus here, you will get negative. What is the meaning of negative change of flux? It is reducing. That's all. Okay. So answer is 60. Have you got it? How it came 60? Once again, direct formula based question. Question number 11, 12, 13. Start solving that. First you solve 11 and 12. No 60 is there in the option. Some mistake will be there in the option. What you solved is correct. Have trust on you. I think answer is wrong. 60 is correct. Yeah. Question number 11. Make it fast.
Change in flux, sir.
What, Andrew?
They are asking change in flux.
That's what is induced EMF, no? What is the formula of induced EMF? Change in flux only, right? Andrew? Faraday's second law. E is equal to d phi by dt, isn't it? Yeah.
But the option has some 25 Weber.
Yeah, option does not have 60. That's what they are saying. It means there is a mistake in the option. Why options should be correct only always?
Okay.
Because we solved it correctly, we got the answer as 60, so I am not trusting the options, that's all. Go to question number 11. Is a good question. Calmly you read the question, then you solve it. Whatever we are solving till now is everything from EMI chapter. After this question, I will go to AC questions. Okay. After this 11th question, we will solve some AC questions. Make it fast. Any answer? Question number 11. Option B for ball. Let us see. I don't know, I have to solve it. They have given the diameter, which will help us to find the area. They have given small n value to you, number of turns per unit length, and they have okay, at center of the solenoid a coil of 100 turns and radius 0.1 is placed with its axis coinciding. It is a mutual induction question. It is a mutual induction question, guys, be careful. So that solenoid has number of turns as 100 and radius as 0.01. It has a lesser radius. Okay, current in solenoid reduces at a constant rate of 0 ampere from 4 ampere in 0.05 second. Change in current is given, time is given, resistance of the coil is given, they are asking charge. Total charge you can find if you have the value of current, because current is equal to charge by time, charge will be current into time. For finding current, we want to find the induced EMF and divide by resistance. For finding induced EMF, we should use E is equal to m into di by dt, isn't it? So E will become equal to m, m will become equal to, m is given, no, but we can find m, mu naught n square n1 n2 a by L. Good question, guys. L per meter you find, L not given means for 1 meter you find. Are you getting my point, guys? I will tell you. Where it went? See, I am telling you, please pay attention. They have given the diameter to you. They have given the number of turns per unit length for which coil? For a bigger coil. The question is like this, if you see. There is a coil and inside that there is another small coil, isn't it? And they are saying the current in the solenoid is reducing at a constant rate of this much. If resistance of the coil is this much, what is the charge flowing through the coil? So we want to find m. M will become equal to mu naught n1 n2 a by L. I will tell you how it helps you. See, pay attention. n1 is given to you, or n1 by L is given to you, n2 is also given to you. What is the value of n1 by L? This much. What is the value of n2? N2 is how much here? 100. What is the value of area? You can find from here. Common area you should find. Sorry, you should not take this area. Take this area. I said you always in mutual induction take the common area. Common area is this only, no here. Don't take the bigger area. Then you will have the value of m you will get. Once you find m, we know that ES is equal to minus m into dIP by dt. Am I right? So m you have already found. Change in current also you know. 0 minus 4 by 0.05. So when you put here m, when you put here this value, you will get the value of ES. If you got the value of ES, divide by, oh they are asking to find charge, divide by resistance, what you will get? Current. Once you get current, multiply by time to get charge. Oh my god. Long. Are you understanding the steps? Pay attention guys. First we have to find the value of mutual inductance by using the formula mu naught N1 N2 A by L. Then by using the formula of E is equal to minus m into di by dt, we have to find the value of ES. After finding E, we have to divide by R to get the value of current I. And once current you got, I is equal to Q by T, multiply current with time, you will get the value of Q. Tell me Sharan.
Sir, that area find for the long circuit.
Why? Mutual area, man. See, because of current flowing here, there is some mutual induction happening in this coil only, no here. Which area will take? Smaller area will take, no? Are you getting a point? What is common in both? This area only is common in both, not the bigger area, right? So if you have understood this, solve it. Maybe later you can do. I have shared the paper with you in the thing. Don't waste time in this. Let us not get stuck here. Time is going to be 8:30. We'll go to the next question now. But procedure is clear to you. These are the steps to be used. Now I am going to go to questions from AC, because I wanted to practice them also. See here. Question number 16 you see. Based upon what we learned in the previous class. Question number 16, make it fast. Any answer? 90. Why 90? An inductor with L is equal to this thing is connected across an AC. Okay, yeah, 90 degree. Directly you can say 90 degree. Are you getting why 90 degree? Because if it is inductor, it became purely inductive circuit. I told you for some time, for purely inductive circuit, the phase difference is how much? How much is the phase difference, guys? 90. So answer is 90 degree. Right? Okay. 17th question. Is it visible to you? The value of R, XL and XC. Is it visible to you? 40, 100, 40. And what they are asking you to find? Power. Power factor they are asking you to find. What is the formula of power factor? I told you in the last class to you, cos phi is equal to what by what? R by Z. Very good. Cos phi is equal to R by Z. R is given as 40. How will you find Z? Root over R square plus XL minus XC the whole square. R is given, XL is given, XC is given. Solve and get the answer. You will find Z. Then you will do cos phi is equal to R by Z. R is known, Z is known. Just direct formula based question this is. Direct formula based question. Power factor is cos phi. Tell the answer by solving. Don't miss, there are two resistance here. 40, 40. It means the total resistance will be 80 ohms, not 40 ohms. Okay, don't confuse here. If you see diagram clearly, there are two R's here, 40 and 40. So R will be 80, not 40, and Z will be root over 80 square plus 100 minus 40 the whole square. Are you getting my point? They have drawn no below the XLR 40 ohms. So the total resistance is 80 ohms here. So R will become 80, Z will become root of 80 square plus 60 square, how much ever it comes.
0.8.
0.8, let us see the options there or not. If you solve this, the answer is coming as 0.
0.8.
Is there, yes, 0.8 is correct. Good. 0.8 is correct. Question number 18. If you need any data, ask me. If you need any data, please ask me. Cos 31.5 is given as 0.852. 0.852. .852 is cos 31.5. Now you solve it.
Sir, option B, sir.
Option
B.
B for Bravo.
Yes, sir.
Okay, maybe. Check. Others. Any idea? Krishna says 76.7. Do you agree with him? Why? How? Any explanation for that? They are saying LCR circuit is there and phase angle is 31.5. That is phi is given to you. You know very well how the diagram looks like. If I draw the impedance triangle, how it looks like, I told in the previous class to you. You remember? The impedance triangle. I said your impedance triangle, this will be Z. You remember or not? This will be R and this will be XL minus XC or whatever, XC minus XL. If I want to write in terms of voltage, I can write this as V across R. This will be V across L minus C, and this will be the source voltage because there is only Z, across Z I am writing. So here they are saying this is only phi. Never forget this. This Z, R and XL minus XC are impedance triangle in terms of resistance. VR, VL minus VC and VZ are the impedance triangle based upon voltages. Impedance triangle I have drawn in the previous class. Please go and check the notes or please go and check the video. I have told in the previous class about impedance triangle if I am right. Check your notes. So, in that I told Z, R and XL minus XC. You know very well, if you multiply R with I, you get V. Same way here also. So, in this case, what will be cos phi? Cos phi will become equal to R by Z, or I can write VR by VZ. Cos phi is given 0.852. VR is given to you. You want to find that only. What is VZ? 90 volts. Multiply, get the answer. If you multiply 90 with 0.85, you will get the answer. Are you understanding this? If you solve, I think what Krishna told is correct. Answer is 76.7. If you have doubt, please ask me. Again I am repeating, in impedance triangle, either you can write in terms of resistance, it will be R, Z and XL minus XC, or you can write in terms of voltage, which will be VR, VL minus VC and V across Z. V across Z is only the source voltage. Z means all three together. If it is clear to you, come to question number 19.
It's actually 76.68.
Okay, then it's fine. Question number 19. Option C. Yeah, looks correct to me. Yeah, because resonating frequency formula is what? Nu R is equal to 1 by 2 pi root of LC. If you want this to reduce, this must increase. And you know very well, if capacitors are in parallel, its value will increase. So the easiest option is C, isn't it? I hope it is clear to you. So question number 20.
Option A, sir. Sir, option A, sir.
Okay, this is, we have just before some time we have did the same question. R is given, Z is given. You can easily find. Yes, cos phi is R by Z. 12 by 15. R by Z here, 0.8 only. 21.
21 option A, sir.
21 is the answer. Which quantity is increased in step-down transformer?
Current, sir.
Current, obviously. Voltage is decreased, current is increased. Good. Then this is not there in syllabus now. LR is removed from syllabus now. So, okay. Yeah, you can try this question. 24? C, obviously. We know that, right? ERMS, IRMS, cos phi. ERMS can be written as E naught by root 2, I naught by root 2, root 2. Actually, we got a derivation itself from this step only. When I derived in the class, after this step only, I wrote 2 as root 2 into root 2. So answer C is correct. You remember? Guys, I hope you are understanding, not blank, right? Power formula is ERMS, IRMS, cos phi. ERMS will become E naught by root 2. IRMS become I naught by root 2. Root 2 will become 2. That's how this formula came. Don't make a face like not understanding. 25, 26, fast. 25, 26, make it fast. 25 and 26. Guys, keep on doing, keep on doing. 25 and 26 from AC. Question number 25, question number 26. Make it fast.
Sir, yes.
25. Maybe we'll solve it. Go ahead. Next question.
Sir, 25 is at A side.
25 you say A, okay. What did you say, Sharon? A only you said, okay. There are two people saying A for question number 25. Let us see what is the answer. Two people have told A. Do you agree with them or you want to change the answer? So what you are waiting for me to solve 25, 26? 25A you got. 26 how much you are getting? 25 let us see how to solve.
26 option B, sir.
B in the sense Bravo.
Yes, sir.
Let us check.
6 option B, sir.
Okay, we'll see. So EMF is given as 200 root 2 sine 100. See this kind of question, please pay attention, something you are learning in this question. Always know that the formula of E is E naught sine omega t, isn't it? So from there you can draw analogy and relate. What is the value of E naught? 200 root 2. What is the value of omega? 100. Are you understanding? So sometimes they won't directly give you omega. You have to extract omega from the equation. So what is the value of omega here? Omega is 100. That is radian per second obviously. And they have told that capacitor is having a capacity of 1 microfarad. So they have given the value of C as 1 into 10 to the power minus 6 farads. Find the RMS value of current in circuit. What is the meaning of RMS value of current? IRMS is how much? What is IRMS here? I naught by root 2, isn't it? So how do you find the value of I naught? What will be I naught? It is a capacitive circuit. You know very well I naught is equal to E naught by XC, isn't it? Same thing that you said. So E naught by XC will give you I naught. What is XC? 1 by omega C. If I multiply E naught, omega and C, then I am going to get I naught. And if I divide by root 2, I am going to get IRMS. Now all the values you have, E naught value is 200 root 2. Root 2 will get cancelled. 200 into 100 into this thing, minus 6. When you solve, you will get 20 milliampere. I hope you are understanding this. I hope, 26 you are saying C. Okay, what you said? 26, I think Krishna and
B option, sir.
B
they,
option, sir.
okay, they are saying B. Hi Akhilesh. Okay, fine. A transformer having efficiency of 90% is working on 200 volt 3 kilowatt power supply. If current in secondary coil is 6 ampere, voltage across secondary coil and current in the primary coil respectively. Efficiency is 90%. Don't forget that, okay? Eta is 90%. What is eta? Vs, or I should write Es, whatever you want to call it. Es, Is by EP, IP, isn't it? So here they have given the value of what things are given. What is the value of this 200 volt? Is it Vs, Es or EP? EP. So EP is known to us and power is known to us, 3 kilowatt. Okay. So P is equal to EP, IP. P is given as 3000 watt, which will become equal to EP. EP is 200 volt. We can find IP easily from here. If you solve it, will come 15. IP will become equal to 15 ampere. We got the value of IP also. Okay. Next, what they have given? Current in secondary is 6 ampere. So current in secondary is given as 6 ampere. The voltage across the secondary coil and the current in the primary coil respectively they are asking. So voltage across secondary coil they are asking, which is this they are asking, isn't it? Current in secondary is known to you, current is primary is known to you, efficiency is known to you, EP is known to you. Put in the equation, get the answer. Put in the equation, guys. This will be 0.9. I need 0.9. So 0.9 times, what is EP? EP is 200, right? 200 times, what is IP? 15 divided by, what is IS? 6. Solve this. 2 3s are, it will become 100 times, and 3 it will become 0.3 times. So 0.3 into 100 will become 30, and 30 into 15 will become 450. So answer can be B or C. Both have 450 volt. So first part, once again clashing because we are getting 450 volt. You said C. Oh, now we are changing. Okay, anyhow. Current in primary is 15, right? B is the answer. Is it clear to you? Are you realizing how the questions will be coming in the examination? If all these things, whatever we are solving from last 1.5 hours, if it is clear to you, you are actually doing the maximum level of question from EM and IAC. Whatever I am showing you, all the questions are from either school exam or some of them are even from competitive examination that I have taken today. Only MCQ I have taken. Have you seen it? There is no theory questions today. Because if you know how to solve MCQ, theory is actually simple. Where you lose marks is MCQ only or numericals only. Everything numericals only I am trying to solve today. Okay, next question, shall we go to question number 27? Tell me the answer here. Frequency is given, amplitude is given. Can you find the RMS value? Guys, what are the options given? Let us check. A is answer. Okay. Have you got A as answer, everybody else?
Yes, sir.
Okay. There are some case study question also. Why don't you try this 30, this question? Is it visible to everybody? 37, 38, 39, 40. Is it visible to you, all of you? Okay, then please go ahead, solve this question.
Sir, but we can't see the graph.
I think graph is not required here. This data is enough. Graph is just to justify the question. But this this data is enough, Kirti.
Yes, sir.
Either it will be too big or too small. What is this? Which one? Maybe. Write the given data. R is known as capacitor of reactance. So XC is given and L is given.
Option D, sir.
Option D, 31.4.
Yes, sir. Yes,
Okay, good. 38.
The 37 option is.
Option B means ball or D for delta, man. Krishna.
Yes, sir. Option D, sir. 37.
Okay. (37), 38, 39. Make it fast.
sir. 38A, sir.
30,
8A.
38A. Okay, let us check.
Yes, sir. 38A, sir.
39.
Sir, that is B.
39. B for ball. Okay. Do you have these answers? Everybody else?
Yes, sir. 39B, sir. 39B, sir.
39B.
39B, sir. Sir, can you go down a little bit?
I'll go. Maybe 40th one you need a table for that. Just tell me the answer in terms of tan inverse, that is fine for 40th. So 37D, 38A, 39B, they are correct answers. 38. A is correct. So anybody has problem in this question? See, everything was given here in the data. They gave R value, they gave XC value, they gave L value, and they have told everything in series. And they have applied a voltage of 200 volt, 50 hertz. Omega is also given, nu is given, omega not, nu is given. From there, how will you find inductive reactance? XL will become equal to omega L. L is known 0.1, omega will become equal to 2 pi nu. Solve, get the answer. Impedance, how will you find? Root over R square plus XL minus XC the whole square. R is given, just given. XL you have found now. XC given directly. Put in the equation, solve, will get the answer. Value of current in circuit. What will be current? Current can be found by dividing 200 by, yes, whatever you find the value of Z. It is connected questions, guys. Without solving this, you cannot solve this. Without solving this, you cannot solve this. And then finally, this question needs tan table. 9 point? What is the value of that? Oh, that 40th? Tan inverse of? How much is that? 1.45. That is answer. Answer is tan inverse of 1.45. Tan inverse of 1.45 is the answer for last question. That is correct. So I hope you have realized in today's class, especially those who are coming for the class regularly, last two chapters that we have learnt recently, how the questions are going to come from those two chapters in the examination. And again I am repeating, this is the maximum level of question that can come in the examination. Yes, Sharon. 55 degree 4 minute. You cannot find without table. They will give you giving. If this kind of question comes, they will give the table, or in the board exam question paper, no, the first paper will have the tan inverse of this value. Okay, don't worry about that. Don't worry about the exam, how to remember this. Concept should be clear to you. Okay, so next class we will be talking about EMWs little bit, and we will start talking ray optics. Okay, so if everything is done, you can drop out. We will meet again in the next class. I have already shared the worksheet in the group. So yes, Anshu, something you are saying?
I had a doubt in the practice questions from yesterday.
Okay, which question you have to share with me, no, in WhatsApp?
No, sir, like I said, 13th question.
I don't have the practice book here with me, man. I'll keep a separate session for you and clear that. Don't worry.
Okay.
Okay. So you have to wait for a minute. Okay. People can start moving. Boys, start moving fast. Yes.
Thank you, sir.
Take care.